Hello students, welcome to MJC Learning. I am Manju Dilip. Today I am going to start with the 12th standard Mathematics Paper 1 first chapter Mathematical Logic Part 3. We already studied different topics in the previous slide. Conjunction, disjunction, negation, implication, double implication and their truth table also. So today we'll start with the topic statement pattern, truth table of the statement pattern, tautology, contradiction and contingency. Statement pattern. Letters used to denote statements are called statement letters. Let P, Q, R, S, etc. be simple statements. Then a statement formed from these statements and one or more connectives, that is and, or, negation, implication and double implication is called a statement pattern. That means statement pattern is a combination of simple statements and connectives. These are two examples given here. Can go through that. Truth table of the statement pattern. A table that shows the possible truth values of a statement pattern obtained by considering all possible combinations of truth values of its prime components is called the truth table of the statement pattern. So we'll discuss through example. We'll do the second example here. In this truth table, you can see there are first column heading is 1, 2, 3, 4, etc. so that you can count the columns properly. And in this statement pattern, inside the parenthesis, Q and P is given. You know the first column, we will start with the simple statements. So P, Q are the two statements in the statement pattern that we already studied earlier. Then in the statement pattern, inside the parenthesis, Q and P is given, so that we written here. So in this one, you have to consider the order of the statement, that is Q and P is given. So you have to consider Q value first, then you will take P. So here true and true is true, false and true is false, true and false is false, false and false is false. And the last column is the full statement pattern. It is the combination of column number 1 and 3. So P or Q and P. So true or true is true, true or false is true, false or false is false, false or false is false. So in this table, P, Q are two statements. So n is equal to 2. You can find the number of rows in a truth table by using this formula 2 raised to n, that's equal to 2 square is equal to 4. That means 4 rows are present here. Similarly, you can find the number of columns also that we'll discuss in this slide. While preparing truth tables of statement patterns, following points must be noted. Parentheses must be introduced whenever necessary. Here two statement patterns are given. First one is negation of P implies Q and second is negation P implies Q. Both are different because in the first case P implies Q you will find first, then you will take the negation. In the second case negation P will find first, then negation P implies Q will find. So both are different. If a statement pattern involves n component statements P, Q, R, then because each of P, Q, R, etc. has two truth values, namely true and false, the truth table of the statement pattern consists of 2 raised to n rows that we discussed in the previous slide. If the statement pattern contains m connectives and n component statements, then the truth table comprises of n plus m columns. That already we did in the previous slide. Now, we can write down the truth table of the statement pattern from the truth table of the first connective. Here in the truth table, we will start from the left hand side. So here given negation P implies Q if and only if P. The truth table of this is this one. Here again, the number of statements are P and Q. So two values are given. So n equal to 2. And the connectives used here are 1, 2 and 3. So n equal to 2 and m equal to 3. So n plus m is equal to 5 columns you can see here. And n is equal to 2. So 2 raised to n, that is 4 rows you can see. Now negation P value we will take first. So negation P means negation of the first column. Negation of true is false, negation of true is false, negation of false is true, negation of false is true. And in the fourth column inside the parenthesis term we have taken, so Q implication, double implication P. So we will take Q value first, then P. So true if and only if true is true, false if and only if true is false, true if and only if false is false, false if and only false is true. Then we will take the full statement pattern. So it's a combination of column number 3 and 4. So false implies true is true, false implies false is true, true implies false is false, true implies true is true. Here again you can see n equal to 2, we already discussed. Now tautology. A statement pattern whose truth value is true for all possible combinations of truth values of its prime components is called a tautology. That means the last column of this truth table, if all the values are t, then it is called tautology. Tautology we are represented by small letter t. The statement pattern P or negation P is a tautology. I'll show you the truth table here. P, so the two values of these are true and false, and negation P is negation of true is false, negation of false is true. Now the combination P or negation P, true or false is true, false or true is true. So in the last column the statement pattern values are only true. So it is called tautology. Now contradiction. A statement pattern whose truth value is false for all possible combinations of truth values of its prime components is called a contradiction. That means all the values in the last column is false, then it is a contradiction and it is denoted by small letter c. The statement pattern P and negation P is contradiction. The truth table is here. P and negation P. So true and false is false, false and true is false. All the values in the last column is false, so it is a contradiction. Next, contingency. A statement pattern which is neither a tautology nor a contradiction is called a contingency. That means it's a combination of both true and false in the last column. So we can see them in this one. We already studied this implication truth table. So here true and false is there. So both are there, then it is called contingency. Important table for all connective. So we already studied negation table, conjunction, disjunction, implication and double implication individually. This is the combined table. That's it. Example. Construct the truth table for the following statement pattern. This is the first example. In this one, P, Q, two statements are there. Negation Q will not consider because that is the negation of the already present statement. So two statements and 1, 2, 3, 4 components, connectives are there. So 4 plus 2, 6 columns and 2 raised to n, 4 rows. So first inside the parenthesis it is P and negation Q is given. To find this one you have to find negation Q first. So we started with negation Q. So negation Q is false, true, false, true. Then P and negation Q. So first and third column you have to take true and false is false, true and true is true, false and false is false, false and true is false. Next is P implication Q. So P and Q, first and two. So true implies true is true, true implies false is false, false implies true is true, false implies false is true here. Then the last column is the combination of 4 and 5 and double implication is there. So false if and only if true is false, true if and only if false is false, false if and only if true is false, false if and only if true is false. So in this one, last column is fully false, so it is contradiction. Next example is P and Q if and only if Q or R. Here it is P, Q, R. Three statements are given. This is the first time we are discussing this type of question. So 3. So 2 raised to 3, 8 rows are there. And 1, 2, 3 connectives used. So 3 plus 3, 6 columns are here. Now PQR you have to write like this. You can write like this also, or you can take other order also. It is not necessary to start with true. You can start with false, 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 then true, 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 that way also. But now we are starting with this pattern. So true and true is true, true and true is true, true and false is false, true and false is false, false and true is false, false and true is false, false and false is false, false and false is false. Next is Q or R. So we are taking column number 2 and 3. So true, 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 false, true, true, true and false. And last column is the combination of 4 and 5. So that is double implication. True if and only if true is true, true if and only if true is true, false if and only if true is false, false if and only false is true, false if and only if true is false, false if and only if true is false, false if and only if true is false, false if and only if false is true. So it is a combination of true and false. That is why it is contingency. Next example. Here in this example, this is a lengthy question. So you can name the first part as A and the second part as B for your convenience. So here already we discussed PQR. You have to write like this. Then inside this parenthesis, Q implies R is given. So we have started with that. Then P implies this is given. That is the next column, and I have given A for as the name here. Then sixth column P and Q that we did. Then P and Q implies R. So I have given another name for this. That is also done. Then eighth column is the combination of 5 and 7. So instead of writing the full statement pattern, I'll write only A if and only if B. Then I'll take column number 5 and 7 values to calculate. So true if and only if true is true, false if and only if false is true, true if and only if true is true, etc. you will do. Then we will finish this like this. So here in this one, all the values in the last column is true, so it is a tautology. Now some exercise questions are given to you. You can go through this. First one is construct the truth table for the following statement patterns. There are 2 questions given to you. And the second one is examine whether each of the following statement pattern is a tautology or a contradiction or a contingency. Thank you.